I'm Daze Thomas, Assistant Professor, Department of Artificial Intelligence and Data Science from SNS College of Engineering. Today, let us discuss about storage management in operating system. Main objectives are to provide a detailed description of various ways of organizing memory hardware, to discuss various memory management techniques including dazing and segmentation, to provide a detailed description of the Intel Pentium that supports both pure segmentation and segmentation with paging. Program must be brought from disk into memory and placed within a process for it to be run. Main memory and registers are only CPU storage can access directly. Memory unit only sees a stream of addresses plus read request or address plus data and write request. Register access in one CPU clock or it can be lesser than one. Main memory can take many cycles causing a stall. Cache sits between main memory and CPU registers. Protection of memory required to ensure correct operation. Base and limit registers. A pair of base and limit registers define the logical address space. CPU must check every memory access generated in user mode to be sure it is between base and limit for that user. You can see a diagram of registers where the base register is given and the limit is also given for every process. Hardware address protection: CPU creates an address and compare it with the base. If it is less than or equal to, then it again compares with the base plus limit. Address must be less than base plus limit. If so, if both the conditions are true, it will be passed to the memory. Next is address binding. Programs on this address binding means it is a mapping of instructions to the main memory. It will be brought into memory to execute form an input queue. Without support must be loaded into address. If there is no support, it will be loaded into address 000. Further addresses represent in different ways at different stages of programs life. Binding of instructions and data to memory. Address binding are of different types. There are three types: compile time address binding, load time address binding, and execution time address binding. Compile time: if memory location known as priori absolute code can be generated, must recompile code if starting location changes. Then load time address binding must generate relocatable code if memory location is not known at compile time. Execution time binding delayed until runtime if the process can be moved during its execution from one memory segment to another. This is a diagram for address binding. First, will be a source program will be sent to compiler or an assembler. Here we'll have compile time address binding. Then it will be converted to object module and object module, then load module. At this time, when the program is with the loader, then we will have load time address binding, and during the execution, it will have execution time address binding. Logical versus physical address space. The concept of logical address space that is bound to a separate physical address space is central to proper memory management. Logical address is generated by the CPU. It is also known as virtual address. Physical address is seen by the memory unit. Both logical and physical addresses are same in compile time and load time address binding schemes. Logical and physical addresses differ in execution time address binding scheme. And we have logical address space is the set of all logical addresses generated by a program. Physical address space is the set of all physical addresses generated by the program. We have memory management unit. It is a hardware device that run that at runtime maps virtual to physical address. To start, consider a simple scheme where the value is in the relocation register is added to every address generated by a user process at the time it is sent to the memory. We have a relocation register and we have logical addresses and physical addresses in memory management unit. That's all for today. Thank you.